Hello students. So as I promised, today is my second part of that vectors lesson. Okay. So in this I am going to explain it to you. Vectors in plane, then magnitude of vector in a plane, how to write the unit vector in space. Okay. And how to write a vector in the component form and the unit vector form, right? Okay then. And how to find its magnitude. Anyway, so we have already studied directed line segment, and also we have studied how to write a vector notations. Okay. And vector addition and 0 of a vector, addition and 0 of a vector, 0 vector, how to write a 0 vector, the meaning of a 0 vector, then subtraction of vector, negative of a vector, yeah, of a vector, and scalar multiple of a vector. Okay, scalar multiple of a vector. Okay then. So today, as I said, we are going to start with vectors in plane. Now look here, there is a diagram in front of you alongside. Okay, I have put x-axis and y-axis, and there is a point P25. This point is representing a vector OP from origin to the point P. Okay, so in this figure, vector OP is shown. Now look here, if you look at this vector, it has 2 means 2i, and how many j? 1, 2, 3, 4, 5 j. Now look here, what is I and j? Let me define that. Let I is unit vector in the direction of x-axis, and j in direction of y-axis. So always you have to take I and j. If you have two-dimensional coordinate system, then I will be the unit vector in the direction of x-axis, j will be the unit vector in the direction of y-axis. Okay, why we require that? To represent a vector of 2 units on the x-axis. Okay, suppose you have a x-axis, so in the direction of x-axis, if you have a vector of 2 units, then we can represent it by 2i. Similarly, in the direction of y-axis, if you have a vector of 3 units, okay, 3 units, then this vector can be represented by 3j. This is the advantage of a unit vector. Okay, now this vector, which is represented by 2, 2 and 5, this is in the component form. Okay, so we can write this vector as vector OP, and this will be equal to 2i. I will write arrow over it. In the book they don't write arrows, they write the bold letters. Okay, and 5j. So this will be the vector OP represented in terms of the base unit vectors I and j. Okay, we can also write it in the component form. So this is equal to 2 and 5, or I can also represent it with I and j. So to represent it in terms of I and j, how I am going to write it? Look here, 2 times I is 1 and 0, plus 5 times j is 0 and 1. Okay, So this is representing vector I, the base unit vector. This is representing vector j. Okay, so I hope you understood it. In the same way, if you want to find any other vector, let me draw a vector here. Suppose this is a vector, yeah, from A to B. Now let us call this x-axis, okay, x-axis, and let us call this the y-axis. Okay, then how many units of I will be there? 1, 2, 3, 4, 5. 5 units of I, and j 1, 2. Okay, so this vector AB I can write as 5I plus 2j, and same I can write as 5 into 1 0 plus 2 into 0 1, or directly I can write 5 2 as a column vector. Okay, this is also called as a column vector. Okay, okay then, so I hope you understood how to represent vectors in a plane, right? Yeah. Now position vector. What is a position vector? Actually, position vector is a vector which starts with the origin, okay, whose initial point is at the origin and terminal point is something else. So this is a vector OA. So any vector, when it is represented in terms of OA, OB, OC, in terms of initial point O, then it is called a position vector. Okay, so suppose if I have a vector here, yeah, suppose A, B, okay, and my x-axis and y-axis is here. X-axis, y-axis, okay. So from origin I will join A. This will be my unit vector OA, and from origin I will join B, okay, OB. Now look here, A has coordinates 1, 2 in the direction of x, 1, 2, 3, 4 in the direction of y. So 2 and 4, right? Okay, B has the coordinates 1, 2, 3, 4, 5, 6, 7, 8, 8 and 1. So let me define, this is the position vector, of course, position vector of A. Okay, now here in the figure, OA is equal to 2 and 4 in component form is position vector of A. Okay, position vector I will write PV, not every time I am going to write the whole word P, position and vector PV, and OB has a position vector 8 1, okay, is position vector of B. Now if I have to represent AB, how I am going to write AB? You have already seen how to add vectors, okay. So if I want to write AB, then what I have to write? AO plus OB, isn't it? So AB will be equal to AO plus OB. Now AO can be negative of OA. You already know how to write negative of a vector, plus OB, or I can also write OB minus OA. Okay, this is called the position vectors of AB. Okay, it is represented in terms of position vector, and now we can write AB as OB means 8, 1, minus OA will be 2 and 4, and finally this will be 8 minus 2 and 1 minus 4, so which will be given by 6 and minus 3. Okay, 6 and minus 3 is the position vector of AB, or finally the vector AB. Okay, its position vectors are 8 and 1 and 2 and 4. Okay, so AB can be represented in terms of its position vectors OB minus OA. In the same way, suppose if you have PQ, then you can write PQ in terms of position vector as OQ minus OP. Okay, if you have XY vector, then this can be represented in terms of position vector as OY minus OX. Okay, if you have a vector CD, then you can write it in terms of position vector as OD minus OC. So I hope you understood what is a position vector. Okay, now write the illustrated vectors in component form and in unit vector form. Component form means as a column vector, and unit vector form means using I and J. Now look at A. How many units it has? 1, 2, 3, 4, 5, 6, 7. 7 in the direction of X and 1, 2, 3 in the direction of Y. So vector A I can write as what I said, 1, 2, 3, 4, 5, 6, 7. 7 and 1, 2, 3. 7 and 3 will be in the component form. Okay, 7 and 3 will be in the component form, and in the unit vector form it will be 7i plus 3j. Okay, so like that I have represented this vector. Now vector B, how many units it has? It is in the negative direction, 1, 2, 3, 4, 5, 6. 6 units in the negative direction. Okay, so it will be negative 6 and 0, because there is no displacement in the direction of y-axis. Okay, so this will be a vector minus 6i only. Okay, I should write with the arrows, no problem. Then vector C, okay, it is 2 units in the direction of X. Look here, 2 units in the direction of X and going down 1, 2, 3, 4, 5, 5 units down. So 2, 5 or 2 and minus 5, because it is going down. This is in the unit component form, and in the unit vector form 2i minus 5j. Okay, in the same way you can find D, E and F. So vector D will be, it is only going up. So up how many units? 1, 2, 3, 4, 5, 6. So it is going upwards only. There is no direction in there is no displacement in the direction of x-axis. So only 0 and 6. So which can be represented by 6j. Okay, E, vector E will be, now it is in the negative direction of x-axis. So 1, 2, 3, 4, 5, 6. So negative 6. And in the direction of y, 1, 2, 3. 3 in the positive direction. Okay, so 3 here. This is in the component form. In the unit vector form, it will be minus 6i plus 3j. Okay, like this I got E. Now vector F, vector f is in the negative direction of x-axis. Look here, 1, 2, 3, 4, 5, negative 5, right? And in the direction of y-axis, it is again coming down, so negative direction, 1, 2, 3, 4, 5, so negative 5. This is in component form. Now in unit vector form, it will be negative 5i minus negative 5j. Okay, so I hope you understood this. Now magnitude of a vector. If we are writing it in terms of components, then how to find the magnitude of a vector, right? Okay, so to write the magnitude of a vector, I am going to use its components, right? So let me draw one diagram of a vector. Suppose this is my vector, okay, vector A. Now in the direction of x and in the direction of y, so suppose it has 4 units in the direction of x and 5 units in the direction of y. So therefore this vector is vector A, which is 4 and 5, 4 in the direction of x-axis and 5 in the direction of y-axis. Okay, now to find its magnitude, what I have to do, I have to write it in the modulus form. This is the magnitude of A, and then I will write square root of x component square plus y component square in the square root. So 4 square is 16, 5 square is 25. So like that I will get 41. Okay, 41 units. Its magnitude. Okay, so I hope you understood. I will write another one. Yeah, this is another vector B. Now let me draw its x and y components. Yeah, suppose this is 7 units in the direction of x and 3 units down in the direction of y-axis. Okay, so this vector B I can write as 7. 7 is in the direction of x-axis. Look here, it is in this direction, and j is negative 3. Okay, and therefore, and if you want to write it in the unit vector form, it will be 7i minus 3j. Okay, so therefore magnitude of B will be square root of 7 square plus of negative 3 square, so 49 plus 9, so which will be square root of 58 units. Okay, so in general, if AB is equal to xi plus yj, then magnitude of AB will be given by square root of x square plus y square. Okay, so I hope you understood how to find the magnitude of a vector, right? Okay, now here some vectors are given and we have to find their magnitudes. So let me write a part of it. Okay, we are going to find their magnitudes, right? Okay, no problem. So let me call it vector A, 3 and 4. So therefore magnitude of A will be square root of 3 square plus 4 square, 3 square 9 plus 16, 25, which will be 5 units. Okay, then let me call the second vector as vector b, which is given as minus 4 and 3. So therefore magnitude of vector b will be equal to square root of negative 4 square plus 3 square. No need to write negative here because we are squaring them. So square of 16 plus 9, which will be again 5 units. Then c will be a vector c given as 2 and 0. So therefore magnitude of vector c will be square root of 2 square plus 0 square, which will be square root of 4, means 2 units. Okay. And in the same way d will be vector d, which is negative 2 and 2. So therefore magnitude of vector d will be equal to negative 2 square plus 2 square, which will be 4 plus 4, 8, which can be 2 root 2 units. Okay. So I hope you understood how to find the magnitude of any vector. It is not difficult. Okay. You have to write in the square root component of the x component is square plus y component is square. Okay. Okay. Now algebraic addition of vectors. Okay. So let I have two vectors. Vector A is 2 and 3 and vector B is 5 and 4. Now their algebraic addition will be vector A plus vector B, which will be the addition of these two column vectors 2, 3, 5, 4, and then respective components we have to add. So 2 plus 5, 3 plus 4, which will give me 7 and 7. Okay. I will take another example. This is first example. I will take another example. Let small p, vector p is minus 2 and 4 and vector b is 5 and minus 2. Okay. Now, I should use p and q. So it should be q. Therefore p plus q is equal to minus 2 and 4 plus of 5 and minus 2. So I have to add the respective components. So minus 2 plus 5 and 4 minus 2. Okay. So look here, I am adding this with this, it gives me this one. I am adding then this with this, it is giving me this one. So the final answer will be 5 minus 2, 3, 4 minus 2, 2. This is my addition of two vectors. So I hope you understood how to write algebraic addition. Okay, vector addition in algebraic form. Now subtraction. Look here. Let I have a vector A 3 and 4. I have a vector B 5 and 7, suppose. Now to subtract A minus B, what I have to do? I have to write the negative of B. So negative of B, okay, will be given by negative 5, negative 7. Therefore A plus of minus B, which will represent A minus B, will be given by 3, 4 and plus of minus 5 minus 7. So finally 3 minus 5, okay, and 4 minus 7. So this will be a vector minus 2 and minus 3. Okay. So to subtract two vectors, what we do? We add the negative of the second vector. From first vector, if you have to subtract the second vector, so add the negative of the second vector. Okay. Okay. Algebraic scalar multiple. Now let A is a vector 2 and 1. Then if I have to find 3A, what I will do? 3 and I will write the column vector 2 and 1, and then I will multiply each component by 3. This will be called as 6 and 3. So this will be called as the scalar multiple of A. So therefore 3A is scalar multiple of A. Okay. So I hope you understood this. In the same way, suppose let B is another vector, minus 2 and 5. So therefore 4B. How I am going to get 4B? 4 times the column vector minus 2 and 5. Then I will multiply each component by 4. So my answer will be negative 8 and 20. This will be my scalar multiple of the vector B. So I hope you understood this. Now we will solve this question. Okay, R vector is given by, vector R is given by 2I plus 3j, and vector S is given by minus I plus 4j. Okay, now we have to find the magnitude of S minus 2R. Okay, so first what I will find? S minus 2R I will find, vector S minus 2 vector R. So I will write them in component form. 2 and 3 is R minus 2 times, I wrote in the wrong way. So I should write S is first. So I will write vector S as minus 1 and 4 minus 2 times vector I. So look here again, S is here minus 1 and 4. So I am writing here minus 1 and 4. Then 2 times R I have to subtract. So R is here. Okay, this is vector R, 2 and 3. Okay, so this will be minus 1 minus 2 times 2, 4. And 4 minus 2 times 3, 6. So look here again, 2 times 2, 4. So 4 is here. 2 times 3, 6. 6 is here. So 1 minus 4. So minus 1 minus 4. And 4 minus 6. So 4 minus 6 I wrote here. So this will be finally minus 5 minus 2. Okay. So therefore now the magnitude of S minus 2R will be square root of minus 5 square. I told you, you can ignore negative sign to write the magnitude. So 5 square is 25, 2 square is 4. It will be 29 units. Okay. So I hope you understood this. Then second vector, R plus 2S. So first I will find R plus 2S. R is 2 and 3 in column vector form, and 2 times S is minus 1 and 4. So I will have to add 2 plus of 2 times minus 1 and 3 plus of 2 times 4. Okay. So look here, 2 plus of 2 times minus 1, 2 plus of 2 times minus 1, and then 3 plus of 2 times 4, 3 plus of 2 times 4. Okay. So the finally it will be 2 minus 2, 0, and 3 plus 4 to the 8, 8 and 3 is 11. So therefore magnitude of vector R plus 2 vector S will be the square root of 0 square is 0, 11 square is 121, which will be 11 units because there is only one component. Okay, so I hope you understood. Then here we have to find the value of k. I want to end this lesson. I think it is getting longer anyway. So to find value of k, let us simplify these equations. 2 minus 5 plus k times 3 minus 1 is equal to 20 minus 11. So therefore what I will do, I will add the respective components 2 plus of 3k. So look here, 2 plus of 3k is here, then minus 5 plus will give me minus k only. Okay, so you can look again, minus 5 minus k, minus 5 minus k, and this is equal to 20 minus 11. Now we will equate the components. So this will give me 20 plus 3k is equal to 20, and minus 5 minus k is equal to minus 11. Okay. Of course, any one equation can give you the value of k, but I will show you that both will give you the same answer. Okay. So 3k is equal to 20 minus 2, which is 18. So k is equal to 18 divided by 3 will be 6. So this is the value of k. Okay. So let me show you from the second equation also that it will not be different. Okay. So minus 5 and plus 11, I will bring this here and take k there, is equal to k. 11 minus 5, okay, 6. So k is equal to 6. So look here, from second equation also we got the same answer. So if you have such type of equations, vector equations to solve, to find the value of unknown, you can use any one of them. It should be correct. Now second vector I will take on the next page. Okay. Oh, sorry. Yeah. Now I will do the same thing. What I will do, I will multiply by 1 by 3 to each component first. So minus 1 by 3 and k by 3 is first component. Now here also I will multiply by 4 by 3 to each part of it. So 4 by 3 into 7 and 4 by 3 into k plus 1. Okay. This right hand side I will keep the same. Now this implies minus 1 by 3 k by 3 plus 7 fours are 28 by 3, and each part I can simplify, 4k by 3 plus 4 by 3, okay, is equal to 9 and minus 1. So equating components, first I have to add. So let me add and then I will equate the components. The left hand side I have to add. So minus 1 by 3 plus 28 by 3 and k by 3 plus 4k plus 4 by 3 is equal to 9 and minus 1. So this I can further simplify as, see here, these two I can bring together, 28 minus 1, 27 by 3, which will be 27 by 3, and the second component will be 4k and k, 4k and k, 5k plus 4 by 3, okay, is equal to 9 and minus 1. Again further I can simplify, 27 by 3 is 9, this I cannot, so let me keep it like this, and is equal to 9 minus 1. Now equating components. So of course the first component will remain the same, only the second component we will equate. So 5k plus 4 over 3 is equal to minus 1, bring 3 here. So this will give me 5k plus 4 is equal to minus 3, then 4 will come here. So 5k is equal to minus 3 minus 4 minus 7. So 5k is equal to minus 7. This implies k is equal to minus 7 by 5. Like this I get the value of k here. Okay. Minus 7 by 5. With this I will end this lesson, because I told you I am going to take only for half an hour. Okay. So Okay then, so I will end this session here. I hope you liked it. If you have liked it, please like, share and subscribe my YouTube channel. For any request, or if you want any free demo lesson, you can contact me on my email ID or on my WhatsApp. Okay, PDF of this explanation, the link of the PDF will be there in the description of this YouTube video. Okay then, bye for now.